Hey guys, this is Simon with Entagma. A while ago, while scrolling through Instagram, I found this guy here who builds custom leather balls. In this specific example, he builds a ball out of so-called Truchet tiles, which is a special kind of pattern which can be arranged in a grid, and however you rotate the separate tiles, it will generate a unique but continuous pattern on the surface. I thought this looked super interesting and wanted to give it a shot in Houdini, so let's dive inside and start. So as usual, let's put down an empty geometry container, dive inside, and in there we start off with a circle. Set the orientation of the circle to be the x-axis, and the divisions we adjust to be 6. So we have this 6-sided shape over here. And next thing we want to do is we append a poly extrude saw. Put that here, wire it up, put the flag on it, and the distance should be 0.5. Of course, we need to make sure that extrude back is also activated so that we have a solid piece of geometry. So this will be our hexagonal tile. Next is to build the inside of the tile, the actual lines that we need to create to build our Truchet tile. So first of all, let's create another circle, flag on here. We also set the orientation to be on the X plane. Uniform scale should be set to 0.5. And the center should be 1 in X direction and 0, 0 on the both other axes. And we will adjust the divisions to be 64, something like that. Next, we will append a mirror saw to mirror the circle on the other side as well. So it looks like this. And if I put the ghosting flag here on our circle, for example, you can see we now get the 2 parts on the right and on the left side. All right, next we want to create a line in the center. So let's type in line and directly merge that with our mirrored circles. Take those two, merge together, put the flag on here. And let's also adjust the line a bit. So the direction should be pointing in Z direction. So it's 0, 0, 1. And the length should be 2. And we will also set the origin to be -1, like that. So we have our one line in the center and the 2 circles on the outside. To give them an outline, we use the poly expand 2D node. Poly expand 2D, put it right underneath here, put the flag on it. And if we switch to wireframe mode, you can see that we basically already have what we want, but the circles are closed here in the center. So we can easily solve that by using a hole saw and put that afterwards and put the flag on it. And it basically just cuts the circles into places so that it's possible to have the inside hollow here. So what we want to do now is also extrude them to get some solid geometry. So we use a poly extrude again and set the depth to be, the distance to be 0.35. And of course also activate output back. All right, so we have our cutout geometry and we have the solid geometry of our tile. And now it's time to bring them together using a Boolean. On the left side, we connect the tile, and on the right side, we connect our cutting geometry, put the flag on it. It's already set to subtract and it kind of works. You see we get some artifacts over here. And this is because our cutting geometry is exactly on the same height in Y than our solid geometry. And we can easily solve that by simply pushing this geometry here slightly upwards. So let's use a transform saw. Put that underneath here, not a trace. Sorry for that. Transform, put that somewhere here and move it upwards. Maybe 0.005 should be enough. It's just a tiny little bit. So you can see it jumps upwards. And if you now activate the Boolean, it looks very, very clean. So next we want to bevel the edges a little bit. So we use a poly bevel, set the distance to something very, very small. So let's see what looks good. Oh, this is already way too much. Maybe something like that, 0.01. And I don't want to bevel every edge that exists, but only the 90-degree angles. So we go to exclusions, activate ignore flat edges, and set the maximum normal angle to be 89. So we only get like bevels here on the really, really sharp corners. Also, I want to adjust the divisions to be 3 instead of 1. And this should give us very nice round corners here. So if I deactivate the wireframe and remove the template flag here, you should see we have super clean and nice geometry over here. So we have some little normal artifacts over here, but we can solve that by using a normal saw. Append here. Set the weighting method to by face area and the cusp angle to be 40 degrees, for example. So this should look nice and clean. And just for visualization purposes, I will go back to the Boolean and activate the B inside A group. And here at the end, append a color saw, restrict that to our B inside A group. Let's set this to be a primitive color and give it a pink color, for example. So you should see something like that. And to be nicely organized, let's put a null at the end and call this one out tile. All right, perfect. So this is our geometry that we want to work with, our Truchet tile. Next would be to generate our grid where we can put those tiles on and then rotate them in different ways. Before we can start to arrange our grid here, let's quickly analyze what we need to do. So let's switch to the top viewport, scroll in a bit, and let's scroll in here. I will quickly create a transform top, put that here, wire it up, and activate the template flag. Go to the viewport and push our tile in the position that we need it to be, and then we can see what we need to do. So as you can see in X direction, we have to move our tile 1.5 units to the right because our tile is 1 unit wide and we need to offset it in this way here. And in Z direction, actually, we need to push it down like half the dimension in the Z direction of our tile. So half the length of this Z-axis, we need to push it down. So we can easily write that up in an expression and let that do the work for us. So for that, I will use a line flag on that here. And let's deactivate the template flag over there. And let's change the orientation to be in Z direction, like that. And let's set the points to be 10 points. All right, and now the length of our line, let me activate points and point numbers so you can see the 10 points here. The length of our line should be adjusted by our expression. So what we can use here is the bbox expression, which actually takes the bounding box of our object that we reference in there and gives us different kinds of information about the bounding box. In order to do that, I could write in the expression directly, but then it would be very long because I have to type in the path to this object. But there's another neat little way that we can use, and this is a spare input field. So just activate your line sub here, click on the cogwheel, and then we add a spare input. So this generates this field over here, and then make sure that under view, show dependency links for spare inputs is activated. And now while having this one selected, just drag and drop your tile in here. And you can see that this purple dashed line is now generated. Let's get rid of this transform sub. And this just indicates that in this sub here, some information is brought in from this one here. So it's referenced in an expression, for example. You can see now we have our path here and we can start to type in our bbox expression here. So we type bbox, open parentheses, then you get this little help box and this shows us what this expression expects. So it wants the string surface node, which is the link to this node here, then a comma, and then it wants to have the type that you want to read out. And the available types are listed down here. So you can check where the X minimum position of your bounding box is or in any other dimension, but you also get information about the size. And we are interested in this one here. So the size of our bounding box in the Z-axis. So instead of typing in this path now, I can simply write -1. So -1 references your spare input field down here, then comma, d underscore c size, close the bracket, and let's click here and see what happens. So you see that now the line actually snapped on this length here, which is the dimension of our tile. So let's click on that to see that better. But as I said, we don't want to offset our tiles by the whole length of the Z dimension. We want to divide that by 2. So divided by 2, you can see that now. And this actually is exactly half the length of the Z dimension. But the problem that we are facing now is, as you can see, our 10 points are now distributed over this length here. But we actually want to have each segment to have this length. So we need to multiply this by the number of segments that we have. One quick reminder, as you can see here, we have 10 points, 0 to 9, but it's 9 segments in between. So you have to take this point number and subtract 1 to get the right amount of segments. So you can check how this field here is called. So the parameter is called points. So simply multiply this one here by a channel, which is called points, like that. And now we have to subtract 1. And to have the right order of calculations here, we have to put this last part as well in parentheses, like that. And you have seen that now the line snapped to this length here. And when you change the amount of points, it will also grow. So this worked. Set it back to 10. Now let's select every second point and move them over to the right. So we take a group range node, group by range, put that here, put the flag on it. We call this one offset. The group type should be points, and we select one of 2 points. So you see that every other point is now selected. Next would be to use a transform sub, put that over here, put a flag on it, and we only want to run over the offset group. And in the translate x, we type in 1.5 because this is what we saw earlier. So you get this zigzag pattern. And if you now use a copy to points sub, put it down here. Left input should be our tile. Right input should be our template points. Put the flag on it. Let me deactivate this stuff. You can see that we now have a very, very nicely organized pattern. Everything is continuous and it's perfectly aligned. And if you go back to your line, you can change the amount of points and it will adjust itself accordingly. Perfect. So now let's take care about the other dimension here. So we can simply use a copy transform, put that behind here. And since we have 2 tiles next to each other and want to copy that, we have to offset it 2 times 1.5 now. So simply type in translate 3 in this case. And this also adjusts perfectly. So if you change the total number of copies here, you can do that. And for the other axis, you can adjust it here. Of course, you can connect those two to sliders or put them somehow together, but I'll just leave it like that for now. All right, so our pattern is created. Last thing we need to do is take care of the orientation of the tiles now. So before we set up the orientation types, let's just see and check what we need to do here. So again, I'll use a transform, wire that up to our tile, put the flag on it, and let's quickly see what we need to do. So basically, we want to rotate our tile around this axis here, and those are our different states that we have here. And as you can see, to get to the next edge, we need to rotate it by 60 degrees. So every 60 degrees, there's a new orientation. And basically, we want to create an attribute which goes from 0 to 5. So the first variant that we have is 0 times 60 degrees rotated, and the last one is 5 times 60 degrees rotated. So let's first of all go down here. We can get rid of this transform sub again, and right after our copy, which is our points, we will create an attribute adjust integer like that, wire that up. And first of all, let's call our attribute rot for rotation. The pattern type should be random. Our minimum value is 0 and the maximum value is 5. So the rest can be adjusted later. So let's keep it like that. And now we need a little bit of vex. I'm sure there's other ways to do it, but in this case, this is really the easiest way to do it. So we use an attribute wrangle, put it right underneath here, put the flag on it, and in here, let's type in some stuff. So first of all, we need to specify the axis where we want to rotate around. So we type in vector axis equals the curly brackets, and we want to rotate around the y-axis. So let's type in 0, 1, 0. Semicolon at the end. Let's go on the next line. Next up is the angle which we want to use to rotate around. So let's call this angle. And this would be 60 times the integer attribute rot. So it reads out the rotation attribute from each point, which is something between 0 and 5, and multiplies that by 60. We have to convert this to radians though. So this is easily done by just typing in radians and put this calculation within parentheses. And last step would be to set up the orient attribute, which you can do like this, at orient equals, and orient is a quaternion attribute, so we have to write quaternion, and here you get the help card again, and you simply write down the angle, which is the radians up here, so how much you want to rotate it, and the axis, which comes from top here, so the axis which you want to use to rotate around. And that's basically it. So if we now go to our copy to points, and by the way, we can select the copy to points and activate pack and instance to make everything nice and fast. You can already see what happened here. So you get this nice distribution and this very nice arrangement of lines. And if you go into your attribute adjust, where we specified this here, you can play around with the seed, for example, and each seed will give you very different patterns. And you can also go into the copy, make much more of those. Let's zoom out a bit here, for example, something like that, and give the line more points as well. So you get this very big pattern, and now it fills up the whole screen, and you can see you get very interesting patterns here. And For example, what I also liked, if you go into your adjust integer like that, you can change the pattern type from random to be a noise. And if you now play around with the noise size, you should be able, if you make the element size very big, to see now groups of orientations here, which I really like. So you get mainly orientations in that direction here or in the other one. You can start to play around with this curve here and change it. So this is a super neat effect and I really like the look of it. Now it's just your imagination what holds you back. So take this here, start to run some simulations through those hallways here or whatever you have in mind. This is basically the end of the tutorial. So I hope you liked it a lot. I really enjoyed building this and I think it's a very cool way to build nice patterns. By the way, while researching, I found this website here as well. You can scroll through it. There's a ton of examples of other Truchet tiles, so it doesn't stop here. There's also 3-dimensional Truchet tiles. Make sure to take a look at that and you can use it in the same way that we built our setup here. So that's it for now. I hope you liked it. Let me know in the comments what you want to see next and I'll see you in the next one. Bye bye.